In today's video, I'm going to show you the concept of Economic 101, return to scale. Okay, it's a very common topic that teaches you about the amount of input you put in compared to the output that you get out in order to measure the efficiency of the business. Okay, so a return to scale is the relationship between, I'm going to write it out here, the input versus the output, okay? And there are three different types of return to scale when you're studying all these. So the first type is called the constant return to scale, okay? Constant return to scale. So what does it mean is constant return to scale? What it means is that whenever you double your input, you're also getting double the output. So in mathematical term, if you are writing it as X and Y, the X for input and Y for output, the 2X that you're putting in will be giving you the 2Y. Okay, so that's the representation of a constant return to scale. Now, there's also another concept, which is increasing the return to scale. So increasing return to scale, okay? So in this case, what will happen is that you're doubling your input, you will get more than double. So it can be triple the output, okay? So the ratio between the output that you get out is higher than the input. It can be 2.5, it can be 3, it can be 4, okay? So that's increasing return to scale. And the last concept of return to scale is called the decreasing return to scale, okay? So decreasing return to scale. Okay, so in this state, what happened is that you're doubling your input. However, you only get less than doubling the output. So I'm talking about like 1.5 the amount of output you are getting. So you know that in this state, you're not getting as the same rate of output to input or higher, right? So if you're 2x your input, you're only getting 1.5 output Y, okay? Now, if you're representing these in terms of graphic, okay, so charts, what you will see here is that for the constant return to scale, let's say I'm drawing a graph like this, and I have the input, okay, and the output on the y-axis, what you're getting is a straight line return, okay? So it's a straight line model, okay? For the second part, so you have an input as an I, output as an O. For increasing return to scale, every input you get in, you actually get the exponent. Okay, so you're getting more than the output. For example, I'm increasing my input a little, but I'm getting a lot more of the output comparing to what I put in. Okay, and the last part is the decreasing return to scale. Okay, so when you're seeing a amount of input and output, for decreasing return to scale, you're going to have a graphic behavior like this. Okay, so you're still increasing your input, but to the point where you're recognizing, so it's around this part, you're not getting as many output as you want comparing to the inputs that you put in until it flat out. You're not getting any more from the output. So that's decreasing return to scale, those three different behavior. Okay, so how do we apply that into something very real? So this is an example of let's say a farming business where you have labor, capital, and output, right? So you recorded the different amount of labor input, capital input, and the amount of output that you are getting from this business. Now, how do we identify all of these or recognizing the return to scale? The first step is we need to measure the change in each of the input, right? So I'm going to measure the change in labor. Okay. I'm also going to measure the change in capital. Okay. And then I'm going to measure the change in output. So I need 3 different columns additional to measure those changes. Okay. And then the last one is I'm going to call return to scale. Okay. So how do I identify these? Let's say the first change is the change in labor, right? So I'm going to show The change in labor is the second round of group of labor minus the first, where you have 10 difference in between. Okay, so you're increasing the amount of labor every group you increase by 10 people. Also, you comparing to the change in capital. So capital here can be machines, can be land, whatever that you're counting in unit volume. So you're going to measure the change in capital. Okay, so it's change in baht. There's one more change that I'm looking to insert in, which is the change in total input. Okay, so we need to measure that. It is going to be the sum of these two, the change in capitals and change in labor. Okay, so that's the total change of the team. And the last one is the change of output. So we're going to measure the difference between the second group of output minus the first one. Okay, so it will give us around 15 for each. Okay, now the last one is we just need to do a return to scale evaluation. So there's a formula that you can use. We're going to use the if function in this case. Okay, so the if function of the formula, and we are going to measure, okay, if the change in output is larger than the change in input, the value that we're going to get, okay, another comma, is going to be increasing. Okay, again, if the change, then now what is the value if it's false? Then comma, we do another if function. Okay, we're still comparing to value in output. Now, but this time, if it's equal to the change in total input, we're going to call it as the constant. Okay, constant. And the last one, if the change in output is less than the change in input, we're going to call it decreasing. Okay, so decreasing. And then that's the equations that you put in. Okay, so you don't need the if function in the last part, because that is the last value that you're going to give for these formula. And you hit enter. Okay, so there's something wrong here. Let me correct myself. Constant and then decreasing. Oh, hey, I'm going to need another bracket that close. So as you can see that as I change my input total, okay, my value of output also changed. Now, let's see if I change those scenario, okay, what if my change in input like this, but I'm getting an output of 65. You can see that the evaluation changes. Okay, so in this part, I'm getting an increasing return to scale, but then it gets back to 75, which is decreasing, because what happened is my changes input stay, but the change in output is higher than the input. Or in this case, the change in output is less than, the output is less than the input. Okay, so that is one way for you to identify, okay, when we have a data set, when you want to look at how my input would contribute to the output, is it increasing, is it decreasing, or is it constant? And what you want to operate is where if it's increasing, you want to keep doing it, right? Until it gets to the constant and it starts decreasing, which is the optimal point you want to stop. Okay, that's all for this topic, return to scale. If you find this useful, feel free to subscribe or like the video, and I'll share with you more of these videos in the future. Take care.